This video is about wave characteristics. Question 1. What is a wave? What do waves transfer? What do waves not transfer? A wave is something which transfers energy. Waves do not transfer matter. Question 2. How are all waves created? All waves are created by vibrations. Question 3. Define medium. A medium is what the wave travels through. So examples are: a rope wave travels through a rope, a water wave travels through water, sound wave travels through air, or a liquid or a solid. A sound wave does not travel through a vacuum. And finally, electromagnetic waves travel through a vacuum, or air, or a liquid, or a solid. We'll talk more about electromagnetic waves later, hopefully. Question 4. Define vacuum. A vacuum is a volume with nothing in it. A vacuum is empty space. Question 5. Define mechanical wave. Give an example. The mechanical wave is a wave which requires a medium to travel. So examples: sound needs air, a rope wave needs a rope, a water wave needs water. Question 6. Define electromagnetic waves. Give some examples. An electromagnetic wave is a wave which can travel in a vacuum. So a vacuum is a volume with no space. A vacuum is a volume with nothing in it, totally empty. No matter. Question 7. List the 7 electromagnetic waves in order of decreasing wavelength, increasing frequency, and increasing energy. So radio waves have the longest wavelength, the lowest frequency, and the lowest energy. And then microwaves, and then infrared, and then visible light, and then ultraviolet, and then X-rays, and finally gamma rays. Roy G. Biv. This means red, orange, yellow, green, blue, indigo, violet. Indigo violet means purple. And Roy G. Biv goes from longest wavelength, which is red, and lowest frequency and lowest energy, to indigo violet, which is purple, which has the shortest wavelength, the shortest wavelength, the highest frequency, the highest energy. Question 8. State the meaning of Roy G. Biv. Means red, orange, yellow, green, blue, indigo, violet. Indigo violet is the color purple. This link takes you to an awesome song. Please do listen to that song. Question 9. Draw an energy versus frequency graph and an energy versus wavelength graph of an electromagnetic wave traveling in a vacuum. So E equals HF. So if F gets bigger, E gets bigger. In this case, F cannot be negative. And E equals HF. F has an inverse relationship with lambda. So that's why the second graph looks like that. Question 10. Define longitudinal wave. Give an example. A longitudinal wave is a wave which travels parallel to the direction of vibration. An example is a sound. Question 11. Define compression. Compression is the location of the maximum density of particles for a longitudinal wave. Question 12. Define refraction. Do not confuse refraction with refraction. Refraction is the location of the minimum density of particles for a longitudinal wave. Question 13. Below is a longitudinal wave. Label the points as compression, refraction, maximum speed to the left, and maximum speed to the right. So if we're above the horizontal axis, the particles are moving to the right. And if we're below the horizontal axis, particles are moving to the left. So you could say A is moving to the right, C is moving to the left, and E is moving to the right. B, it's not moving at all. It's between A and C. So B has something moving to the right to its left, and it's something that's moving to its left to the right of it. And D is also not moving to the right or left. It's not moving. So it's between particle C, which is moving to the right, and particle E, which is moving to the left. So A has a maximum speed to the right. B is a compression, because in between it, A and C are moving towards B. C has a maximum speed to the left. D is a refraction. Okay. Particles C and E are moving away from D. And point E, that's the maximum speed to the right because it's above the horizontal axis. Question 14, define transverse wave. Give an example. A transverse wave is a wave which travels 90 degrees to the direction of the vibration. So examples are electromagnetic waves, rope waves, and water waves. Question 15, define crest. A crest is the highest point in the wave for a transverse wave. Question 16, define trough. A trough is the lowest point in the wave for a transverse wave. Question 17, draw a transverse wave, label the crest and trough. So the crest is the highest point, the trough is the lowest point. Question 18, define wavelength, lambda, units. A wavelength is the length of a wave. It's the distance between two identical points in a wave. Like the distance from the crest to the crest or trough to a trough. Wavelength has units of meters. Question 19, define period t. Units. The period of a wave is a time for one wavelength to pass a fixed point. Period has units of seconds. Question 20, define frequency f. Units. The frequency of a wave is a number of wavelengths which passes a fixed point every second. So it has units of cycles per second or revolutions per second, but cycles and seconds are not real units. So it has units of 1/seconds or hertz. Question 21, state the equation which relates the speed, wavelength, and frequency of a wave. V equals lambda over t. This is a mistake. This should say lambda f. There should be an f to the right of this lambda. My fault. Question 22, a single wave pulse on a string or in the ocean travels to the left. Determine which direction the points in the string move after a short moment. So this is not a single wave pulse. This is wrong. It's not a single wave pulse. Okay. So after a short moment, you're going to draw another wave which is traveling to the left. So A is going to go down, B is going to go down, C is going to go up. Because imagine this wave, draw the same exact wave, but to the left of this wave. So it's like you see two sine waves. And right below A, you're going to see a wave. And right below B, you're going to see a wave. And right above C, you're going to see a wave. And right above D, you're going to see a wave. So A goes down, B goes down, C goes up, D goes up. E goes down, F goes down, G goes up, H goes up. Because the wave is traveling to the left. And after a short moment, what happens is this wave moves to the left. So draw another wave to the left of this. Question 23. What will be the wavelength of a wave which has a wave speed of 0.560 meters per second and a frequency of 4.40 hertz? So V equals lambda F. Solve for lambda. Question 24. A wave has a period of 2.2 seconds. What is the frequency of this wave? So F equals 1/t. Question 25. A wave has a frequency of what? 14 hertz. What is the period of this wave? T equals 1 over f. Question 26. You're at the beach sitting on a pier in the water and you notice that the water level where you are sitting rises and falls once every 4.1 seconds. What is the frequency of these waves? Okay. So the period is 4.1 seconds because when it rises and falls, that's the time it takes to go up and down. So that's one period. Period is 4.10 seconds. Question 27. A wave has a frequency of 5.5 hertz and a wavelength of 2.5 meters. What is the speed of this wave? So V equals lambda f. Question 28. What information can we obtain from a displacement versus distance graph? Well, we could determine the amplitude and wavelength. So here's an example. A displacement versus distance graph of a sound wave traveling at 340 meters per second is shown below. Both the vertical axis and the horizontal axis are in meters. Determine the amplitude, wavelength, frequency, and period of the wave. Well, the distance from the center to the middle is like 2.5. The wavelength, it's going to be the distance from one crest to another crest. So it's like 2.15. The speed, V equals lambda f. So the sound wave is traveling at 340 meters per second. So V equals lambda f, solve for f. F equals V over lambda. And finally, T equals 1 over f, where T is the period. Question 30. A displacement versus distance graph of an electromagnetic wave traveling at 3 times 10 to the 8th meters per second is shown below. The vertical axis is in meters while the horizontal axis is in 10 to the minus 6 meters. Determine the amplitude, wavelength, frequency, and period of the wave. So the amplitude is 2. The wavelength is like 1.5 times 10 to the 6 minus 6. The solution says about 1.6. Okay. V equals lambda f, solve for f. And T equals 1 over f. Question 31. What information can we obtain from a displacement versus time graph? The amplitude and period. So question 32, a displacement versus time graph of a sound wave traveling at 340 meters per second is shown below. The vertical axis is in meters and the horizontal axis is in seconds. Determine the amplitude, period, frequency, and wavelength of the wave. So the amplitude is 4 meters. You could see it goes from the middle to the top. Period is a horizontal distance. It's not the wavelength anymore. So period is about 2.1 seconds. F is 1 over T. V equals lambda f. So now let's solve for lambda. Question 33 is a similar problem. The displacement versus time graph of an electromagnetic wave traveling at 3 times 10 to the 8th meters per second is shown below. The vertical axis is in meters and the horizontal axis is in 10 to the minus 6 seconds. Determine the amplitude, period, frequency, and wavelength of the wave. So the amplitude you see is like 3.5. The period is from crest to crest, which is a 3.2. Frequency is 1 over period. V equals lambda f, so let's just solve for lambda. Question 34, define intensity. Units. Intensity is power per unit area, which is units of watts per meter squared, and it's a scalar. Question 35. What is a mathematical relationship between the intensity and amplitude of a wave? What about the energy and amplitude of a wave? Draw an intensity versus amplitude graph. So, intensity is proportional to amplitude squared. And energy is proportional to amplitude squared. So example, if we double the amplitude of a wave, then its intensity increases by 4, because this is going to be 2 squared, which is equal to 4. If we triple the amplitude, 3 squared is 9, so the intensity increases by 9 times. Question 36. A physics student sends a single wave pulse along a string such that the amplitude of the wave pulse is 0.440 meters and the energy content of the pulse is 3.5 joules. Another physics student sends another wave pulse along the same string with an amplitude of 0.880 meters. What is the energy of the second wave pulse? So E is proportional to amplitude squared. So E1 divided by E2 equals A1 squared divided by A2 squared. So plug in everything we know and just solve for E2. So that's the answer. Part B, what is the energy of a third wave pulse if the amplitude of the third wave is 0.220 meters? So do this, you get 0.875 joules. Question 37. A physics student sends a single wave pulse along a string such that the amplitude of the wave pulse is 0.555 meters and the energy content of the pulse is 3.33 joules. Part A. Another physics student sends another single wave pulse along the same string with an amplitude of 0.111 meters. What is the energy of the second wave pulse? Once again, energy is proportional to amplitude squared. E1 divided by E2 equals A1 squared over A2 squared. Solve for E2. What is the energy of a third wave pulse if the amplitude of the third wave is 0.444 meters? So use this equation. Solve for E3. Question 38. What is a mathematical relationship between the intensity and distance from a wave source? So intensity is proportional to 1 over distance squared. So if we double the distance from a wave source, then the intensity decreases by 1/4. And if we triple the distance from a wave source, then the intensity decreases by 9. Question 39. A physics student has a really loud and annoying physics teacher. When the student is 12.5 meters from his teacher, he measures a sound intensity of 145 decibels. What would be the measured intensity of the loud and annoying physics teacher if a student is 20 meters from the source? So we have this relationship here, which is from this relationship. So this is our solution. Question 40. A physics student has a really soft and gentle physics teacher. When the student is 20.5 meters from his teacher, he measures a sound intensity of 12 decibels. At which distance does a physics student need to be from his teacher to hear the teacher with a sound intensity of 30.5 decibels? So now we're going to solve for x2. So the student's going to have to move closer, yeah? Question 41. Imagine a boat which is in the middle of the ocean. Several water waves passes under it. What happens to the boat? Does it oscillate vertically? Does it oscillate horizontally? Both? Neither? The boat will oscillate up and down. The boat will not oscillate left and right. Question 42. Compare the speed of sound in a vacuum, in air, and in a metal. The speed of sound is the fastest in a solid, then a liquid, then a gas. The speed of sound in a vacuum is 0. So this is important. As the density of the medium increases, the speed of sound increases. Question 43. Compare the speed of an electromagnetic wave in a vacuum, in air, and in a metal. The speed of an electromagnetic wave is fastest in a vacuum, then air, then a liquid, then a solid. The speed of an electromagnetic wave in a vacuum is about 3 times 10 to the 8th meters per second. And it's much more fair to call this the speed of an electromagnetic wave in a vacuum as opposed to the speed of light in a vacuum, since all electromagnetic waves travel at the same speed in a vacuum. So radio waves have a speed of 3 times 10 to the 8th meters per second in a vacuum. Same with microwaves, same with infrared waves, same with visible light, same with ultraviolet rays, waves, same with X-rays, and same with gamma rays. So it's not fair to call it the speed of light when all of these other electromagnetic waves also travel at the speed of light in a vacuum. And as the density of the medium increases, the speed of electromagnetic waves decreases. Question 44. For sound waves, pitch means frequency and loudness means amplitude. So this is an example. The speed of sound waves at 25 degrees Celsius is 346 meters per second. What would be the wavelength of a sound wave which has a frequency of 512 hertz under these conditions? V equals lambda f. Solve for lambda. Question 45. The speed of light waves is 3 times 10 to the 8th meters per second in a vacuum. What would be the wavelength of the radio signal generated by WCBES FM, given that the frequency assigned to it by the FCC is 101 megahertz? 101 megahertz is 101 times 10 to the 6 hertz.